We also talked about yesterday the 5 callback prevention steps that we have. Which one of those 5 steps has traditionally caused us the most issues when it's not addressed? Drain. Yep. Drains. As simple as it is. Why are drains such a disaster?
Water damage.
Water damage is the biggest thing. When it actually goes wrong, it costs so much money and it creates such a headache. It's also our #1 call out. The next thing we were going to talk about is our flow switch, wiring them in series versus parallel. Raise your hand if you don't have a clue what I'm talking about, series versus parallel with the flow switch. Just our apprentices, only 3 of them don't know what I'm talking about. All right, so if you wire them properly, you have one end of a flow switch going to our 2 reds, go to our thermostat and our condenser. And if we follow that back to the flow switch, it has the ability to open that if it backs up right here. And then power, which is coming from our red inside our unit, will never make it, it'll stop here. It'll never make it to our thermostat and our condenser. So it shuts off the unit. Make sense?
Mm-hmm.
Now, if this one doesn't back up and this one does, same story. Power never makes it to our red wires. Now, the mistake that can easily or commonly be made, instead of wiring them in series, if you wired them parallel, it would come up like this. You would have this one tying into red, and this tying into red, and then off of this float switch, it would come up and tie into red as well. So basically, the reason this happened is because you know how to properly tie in one float switch, so you do the second one the same way. A float switch should tie from red to red, coming off our thermostat red to red going to our controllers. And since you know how to do that and you know that's right, you get a second float switch and you do it the same way, from red to red. But in this circumstance, if this trips and this wire breaks, you see power still has a path through this float switch to keep the whole system running. So now our pan is overflowing, but the rest of the system is running. Now, if this one tripped, power would still have a path through this float switch that's not tripped yet, and it would continue to overflow inside of our system and soak our unit. So we have to make sure when we're wiring it in that we actually, I'm going to leave it like this so Jesse Claire can come in here and be like, oh, wait, that's parallel. We have to make sure that we actually are wiring it in series so that either one breaks stops the path from making it all the way through. Next thing on drains. We didn't talk about this much, but the unit being level in a horizontal application. So have anybody seen drain issues in horizontal applications from the unit not being level? What about on a, what's that called, vertical application? Yeah, right? And so the drain pan inside the unit, either in horizontal or in vertical, has a natural design pitched. It's thicker, has little feet on the backside that will lift it up, and it pitches naturally towards the drain. And so if you either try to overcompensate that by giving it its own pitch to the drain, you can sometimes throw off the way that it's pitched. The water will pile up and spill out of another side, depending upon how much it's splashing in there, how much return speed. You're always best off having it level. If it were to pitch slightly, it better pitch slightly is the key word, in towards the drain. But I don't like people overdoing that and creating too much pitch, and then it can put puddles in the sides of your horizontal pan, and if you have airflow issues, that will splash out. But, so the goal is to aim at level. So if you show up and you got a horizontal system, and in here it's soaking wet, inside. You open the panels, put your hand down on the insulation, it's soaking wet. Let's talk about some of the things you need to look for. What could be causing that?
Frozen coil.
A frozen coil. All right, so if the entire coil froze like a giant block of ice and then melted fairly quickly, it might be too much for the drain to handle, too much water, and we could back up, or it would just drip off of the sides and down the panels as the ice is pushed against the cabinet, the ice is melting down to the side. So usually if you're showing up and it's already wet in there, the ice has melted already and you might not see it. So turn on the system and make sure we're not in freezing conditions. I like that, frozen coil. What else?
High static.
High static. So how would high static create a wet area in the bottom of that?
Pull water off the coil. Certain circumstances.
Yep, so we have our coil in here. And the airflow is going so fast, it's whistling in there so hard that normally when it might drip off the edge into our pan, let's roll our pan out here. Perfect. The airflow is actually catching the drips and spitting them off into here. And so if you have that much of a high return static where there's whistling through like that, what could you do to fix that problem?
Lower the static.
Lower the static. Okay. Appreciate that. Ding! It's got a little wand out there. Lower.
Just cut a hole in it.
Giant hole in the attic in our return, that would do it. Okay, so we either look at the design of the return and find out if it needs to be improved. The design of the filter, can it improve? Anything that improves that static. And to find out if there's room to lower the airspeed of the blower. Potentially it's just set way too high. And is there room to make adjustments on that? And then if all of that isn't an option, they do have high static return kits that can be installed to redirect the air so that it basically slaps the air as it comes in here rather than letting it hit with its full force into those fins and push the water out. Again, when you put something in there on a high static system and you put something in there to block or change the design of your air, you're creating more static, right? So it's not a great fix. Some systems, you've done everything you can, and they have a drip high static attachment, which basically means this little tube that's right here that collects water and dumps it back into the pan. There's one that goes on the opposite side as well. If there's so much static pressure, sometimes it'll force water off of the opposite side. So you have another high static tube kit that's oriented the opposite direction and can plug on the other side of the coil. Does everyone know what I'm talking about with the tube that comes off the side of the coil in your horizontal application? Appreciate you finally shaking your head, admitting that you don't know. It's a step to growth here as an apprentice. That's great. Okay, so feel free to look that up if you don't know that. Moving right along, what else could be flooding our air handler?
Cracked pan.
Cracked pan. So this is a pretty common one. We have a coil sitting in tension, and it could be vibrating or the weight of it, and it's just always held, and then the base of the pan cracks somewhere along there. This can be a monster to track down and find, right? How do we diagnose a cracked pan, Irving?
You look at it.
Okay, let's say it's
You
in
can
a
do a
location
standing water test.
Okay, standing water test, describe that.
So you could cut and cap off the drain right out the air handler, and then fill up the pan with water. And if your water level starts to decrease with nothing running, then you know that it's leaking from somewhere in that
Perfect,
area.
I love it. So you put a cap right there,
Mhm.
make sure it's watertight, you can see it if it were to drip out of that cap. Fill the water up like you said. Now, if you hadn't already checked that your unit's level, maybe it's tilted towards the back of the pan, and you start filling it up, you might get dripping off of the end because it's just unlevel, right? You have to pay attention, use some common sense, use your eyes. in this. Always first be checking if this unit's level, you're finding water in it. Check for the easy fixes first. And then, so if that pan does have a crack, there's still, water's gonna keep dripping, it's gonna slowly come down. You might have to wait 20 minutes. I mean, it depends on how big that crack is. Some of the problem is that you have a crack in there that drips really slowly until it's running, and it moves the tension of the coil a little bit with the air pressure or the vibration. So you can fill that up and sit there and watch it, and you can grab the coil a little bit and move it, and see if you see the water just start moving a little bit faster. You'll try to aggravate a potential crack there. When's the most common time for a coil to get cracked? What causes our cracked coils other than vibration and,
Cracked pan?
yeah, that's what I meant, I'm sorry, pan, cracked pan, thank you.
Installation.
I don't know what he's talking about, insulation?
No, installation.
Installation, yeah,
Mhm.
whether it's the installation day or the installation of a new coil. Pulling the coil in and out, it's easy to cause too much tension in one area, you're trying to force it. So just think about that when you're installing your coil. One, use all the braces and supports that are there for horizontal application. That way your coil isn't pulling with too much tension. All right, anything else come to mind as a potential cause for our water being in the bottom of this?
Clogged drain with failed float switches.
There we go. Brings us to testing our float switches. Could have a clogged drain and either a failed switch or a bad pitch in the switch, something like that, that's causing a problem.
Or how it's wired.
On a maintenance, what's a good process for, what do you guys use for testing a float switch on a maintenance?
The float switch.
Okay, we'll talk about like when and how you confirm that it's,
Turn it upside down while it's running, so it turns the system off. You
Okay.
hear the refrigerant stop pumping.
that's good. Yep, so you actually need to witness that or hear the refrigerant stop pumping, make sure it's turning off. Your blower has a time delay on it, so it's not always gonna shut off. And hopefully you're not standing there waiting 60 seconds for that blower time delay to shut off. You can either hear it if the refrigerant's pumping or see the thermostat. Tyler?
Checking continuity with a meter.
You can check continuity with the meter, put it in ohms, read across it. Anybody have a problem with doing that on a maintenance?
I found that when I trip it and test continuity, it would say that it's not working. But then when I actually turn on the system and I trip it, it works. It might be it could be that it's partially starting to fail, and that I've been maybe not.
It could also be that your meter was not doing the beeping continuity tests and you were getting an ohms reading across it.
No, the beat.
It did beep, yeah. Well, I don't have an explanation for that. That was probably magic. So, but,
I like
Yeah.
checking 24, 24 coming in, 24 coming out.
yep, instead of ohms, you could just do voltage in and out. That way you don't have to turn off power and disconnect it. A little bit faster. Testing it while the system's running, if you're already there for a maintenance, a little bit faster. You guys should be thinking about the timing of it though. How can I do this in a way that doesn't have me sitting here waiting? But, go ahead, Alex. Alex?
Awesome.
Hey, that's not the only word I've messed up already today, so don't take it personally.
I do my maintenances backwards from everyone else because I test first, but I will, after I'm done testing, walk in, trip the float switch intentionally, listen for the refrigerant to stop pumping, and then I'll walk out, go fill my water jug, stuff like that, hook up my vacuum, that way that when I come back, the blower is already off, so I can remove the panels without the insulation coming off.
Fantastic. Put it in your process somewhere where you're not waiting. That's beautiful about that. But always test our float switch. That's when we have trouble with clients and major money expenses. And it used to be that it was very rare to have a failed float switch, but not so much anymore.
It's also good to notate that you tested it.
That is huge. If you could note-
Please throw it in them notes.
Yeah, it's so
Just
huge.
Build such a nice case. Document everything, right? You guys know that. Document everything
Yeah.
you did. That's just a really, really helpful. It's in the notes, it gets sent to the client, proves that we did it.
Yeah.
There's no guessing.
That's huge. Okay, I think we've covered a lot of the potential causes for flooding in there.
I got one more.
Yeah.
Make sure the plugs are in the back.
I do have plugging unused ports. So you have hookups for your drain on the back side of it, and depending on the manufacturer or who replaced the drain, you could have just forgot to put the plugs on the back side of the coil. And if it's tilted a little bit and the water's leveling up. So yes, plugging the drain ports. I don't know if I mentioned last time, but we did have a house flood because the ports weren't properly plugged in the pan. I went to one, but it wasn't just a house plug. The humidifier pan didn't have a port, and it was a mold disaster. There was no mold there, but the client was terrified of mold, and it's why they purchased a dehumidifier. And so when water started pouring through their ceiling, it took a lot of reoccurring visits and drying out our home and dehumidifiers to like prove that there wasn't going to be mold there growing because of one water event. Yeah.
I've had float switches piped directly to the drain pan, and that water gets sucked right back out so that it doesn't trip it, unless it was kind of on a pitch. And it had like a 90 kind of pitching down a little bit so that water can stay in.
Just coming straight out of the unit
coming
versus
straight out.
coming out and pitching
Exactly.
down.
Yeah.
It's good. Especially on the horizontal applications where you might have a slight pitch or your pan's not completely level, it'll be draining out the backside before it always fills the flow. Anytime you have upstairs system, you have attic system, we're not playing with the pitch of the float to get it not to trip so easy. We're not messing around. We have that float pitched down. We want to catch every overflow. We want to be there every time water goes into the float switch. We're not messing around with trying to just get the customer by. All right, moving on from testing the float switch and plugging the holes. We have, okay, what do you do when a drain is clogged and you can't break it free?
Water pressure in the sink, no such thing.
Okay, Elliot says no such thing.
Garden hose on the outside.
Garden hose from the outside. So basically your garden hose is gonna have somewhere between 45 PSI and maybe max like 70 PSI. But it's pretty safe for PVC connections. And also that water is a huge force. And usually it's easier to control than your nitrogen tank, trying to blast out something. Potentially with nitrogen, you can blow out a weak joint somewhere in between the walls, below your platform. It's there as an option using nitrogen if you know what you're doing and you're regulating the pressure very well, you're watching that closely. However, I really like to start with a water hose from the outside in. And I'll grab the PVC and the hose and I'll seal it with my hand and you'll get sprayed. But what that allows you to do is you feel the water rush in and you feel hit the resistance, and either it breaks free and you can feel that pressure in your hand, or it's blasting water in your face because it hasn't broken free yet. And I'll usually on, off, on, off. I never have a water hose on there more than 3 seconds, I would say, because just in case it actually has broken free, what happens if you just hold the hose onto that drain line and flood everyone inside, right? And so I will have cap inside. I want the water to go all the way up into the air handler, potentially dump some nastiness into the return box. But anything's better than just like the cap off and we're flooding a closet upstairs. I remember in training, technician, he used to take a lot of pride in being able to blow a drain out with his mouth. Yes, Kirby. And he called himself this senior tech. And so when you're with someone else and you're doing the hose method, you can send them up there to watch the drain and make sure that it doesn't get like dumping into the closet. So we're on the phone together and I'm like, all right, I'm gonna hook up the hose. And he thought, I'm gonna break it free last second with my mouth and show him that I can do this. And he got blasted in the mouth and in the face with everything that and that whole closet was just filled with nastiness and he had to clean it all up, including rinsing his mouth out. It's great. One of my best moments. I enjoyed it thoroughly. So yeah, there is that risk of dumping water inside a house. And so, yeah,
I don't know anyone else that really does this, but one thing that I do, I'll hook up a vacuum at the outside condensate line and then run warm water inside at the air handler. So I call it like a push pull.
that's how we
method.
clean. That's how we clean when we clean.
Okay.
So we're talking about, I should have prefaced that, when the vacuum doesn't break it free.
Okay.
Yeah.
Okay. Right, so
Which can be kind of rare. The bigger your vacuum, the better. I did notice that too. It stopped happening to me when my vacuums got bigger. But yeah, yeah. Hot water will actually break things up more. But if your whole drain's already filled with water and you dump hot water in the top, it's gonna be a long time before the rest of that water gets super hot. And you're probably never gonna make your actual joint. Only if it's flowing will hot water break the rest of that free.
I really like my auger.
Your what?
My auger,
Go ahead.
the snaky snake.
Yeah, the drill under, the snake,
Yeah,
I use that a lot.
Yeah.
I've used like nitrogen.
I've never used it to break one that I
I
couldn't break free.
Yeah, I could. I put the back. That's my
Cause they
first.
don't seem strong enough, but that's good if that
You,
works.
you gotta hit it for a minute,
Uh-huh.
but like you'll reach that point where you can feel that okay, I'm past all the 90s and 45s and I'm down the straight line and I'm hitting something
Mm-hmm.
and you can just back and forth kind of plunger it.
Nice.
But that I prefer. That's my first resort before I try and blast it with nitrogen.
Okay, good. And before you blast it with nitrogen, you should use a garden hose.
Yes, that.
Okay, what happens when we have a leak? That only happens when it rains.
That's the roof.
Oh, Chase isn't sealed.
Okay. Or the roof.
Aw.
And we do get those calls.
No water shorting
Yeah.
dry, turning the condenser on,
Often
freezing
you
the
have
oil.
water coming out of a vent under an air handler, and it could be the roof. And the vent is just the hole in the ceiling or the lowest point,
I was
and the water's working its way down there. So always keep in mind, if you have water leaking somewhere and you open your air handler and the return's dry and the platform's dry, okay, maybe I could peek into the roof and see if it's there. And how would you find a leak up in the roof if it's not currently raining?
Look for the light.
Okay, no, that's not gonna be that big, you're not gonna see light.
You might see growth.
Just bring the hose up to the roof.
Don't use the garden hose.
garden hose.
No, we're not that desperate. If you have a leak coming in from the roof,
You
you're gonna
usually
see
see water standing on the
water
plywood.
stains. You're gonna see some water stains. And you remember where it dripped out? You can usually see a water stained path back up to that piece of wood that it's dripping on. You look up and there's a little water stain coming down on the stud.
Additionally, I would, I don't mess with it. Most of you guys have the cameras. Adriel, another horror story pump blew out, and there's water everywhere. You can see thermal anomalies.
That's good, I didn't think of that.
So, you have tools, that's not what it's, maybe what you're thinking it's used for, but that can be an indication of wet spots. It's gonna be cooler, where it's wet, so
Yeah,
might
the
be able to
plumbers use the
visually-
thermal cameras for finding
visually
water
see
leaks.
that and kind of just trace it and follow it and at least give you an idea to where to continue to look.
I like that.
I'm still waiting for my camera.
You are, huh?
I'm waiting.
I got myself one. I
Oh.
got you one. Great. The other one was chases.
Yeah.
So if you have a chase that's not sealed inside, under the platform, and outside, and in Claremont especially, all the hills, homes on different elevations, it's not too unusual to have water come in, be flooding that chase in a heavy rain, and dumping inside and just spread it throughout the house. And you're looking for a drain problem, but you have to get in, open the return box and peek at that and you see that the water's coming from the chase. Or you could have that, it's not a rain issue, but you have a broken chase line and it's sealed enough that the water's filling that whole chase and it happens to not be sealed inside watertight and it's seeping under that mastic and stuff into the home. So keep in mind drain issues in the chase connected to rain. All right. Leaks that only happen when the drains back up. So we do have situations where everything drains completely fine in between floors, under platforms, upstairs, maybe in the attic. And then randomly, we have this just crazy leak in the drain. We go, we flush out the drain. We notice it didn't back up to the float switch. We just have random leak spots in the house. What's going on there?
Something's not glued properly.
Something's not glued properly, so I'll just draw an illustration of that.
Or insulated properly.
Let's say we have a 90 here, which we talked about insulation last time, so I won't go there this time. When the system's running, our gravity drain, we just have a little water running down the edge of the pipe and working its way outside. Just a little drip of water. If this right here is not glued and not sealed properly, it might never show up until the drain backs up with water. It clogs down there and slowly backs up. And as soon as it hits this point, this is now a gushing leak out of where it wasn't sealed before. So you don't ever know what's happening until a leak situation. Or if you're dumping a lot of water in, you could see it. You could cap the drain outside. Same as the pan, crack pan, cap the drain outside and fill the water all the way up and see if the water level goes down. And you would know you have a leak platform in between walls and ceilings. And in that situation, you would do that if you already have some ceiling damage, some drips you're trying to isolate, you know, what could be causing this and where. Now, potentially, that could just be this T right here, right? We have a T. Excellent, I knew that was T. So potentially there could just be a poor, what's the opposite of that? A poor glue joint there on the T here, or maybe in the horizontal section coming in right here. We have a poor glued spot, and this is all insulated. Let's say this is all insulated, coming down into this platform. Either one of these potential leak spots will fill up some water inside the insulation, soak it, and then right down to the lowest point and drip. So it doesn't necessarily mean I need to open the ceiling here and find the leak because it's dripping on the ceiling. Always start with what you have access to. Reach into that insulation, grab it. In here, is it soaking wet? Okay, I need to keep moving up. If it's wet there, I need to keep moving up. Water goes downhill and find the source of this leak. Don't immediately start cutting open drywall, assuming. And before you were to cut that open, hopefully you could access the return underneath the air handler and cut open the return box. Ductboard's a lot easier to fix than drywall. And look there before we start going into our ceiling.
Will you say that again? Ductboard's a lot easier to fix. What did you
Ductboard's
say?
a lot easier to fix than drywall.
One more time, just for clarity's sake.
Ductboard is much easier to fix than drywall.
That's good.
Sure.
Thanks.
Does that speak to you?
Yeah.
As a manager?
Huh?
Panel installation and condensation on the air handler, water on the platform. Alright, common customer complaint, you got a brand new unit, there's water on our platform. It looks a little gold, might look a little brown, we got puddles down there. What tarnation's going on? Anybody wanna help me in this next 4 minutes, Tyler?
Keeping the thermostat low, so it's hitting dew point.
Okay, dew point, so it's running really cold, could be a dehumidifying unit, it could be set in thermostat low, and the whole outside's just kind of sweating and hitting dew point. There's not always a fix for that. It might just be worth it for them to keep that cold and use dehumidification and to sweat. If that's the application, high dew point numbers in their garage, and we're just reaching that. However, if we don't see it sweating on the outside, but we're still getting water pool on the bottom, what do we assume then?
Insulation.
Suction line.
Insulation and suction line. Go ahead, speak more on that. I'm getting tired of talking.
Yeah, I used to fix a lot of those issues. And, yeah, you can see.
Tell
that.
us how.
Well, you can get a little piece of insulation on tape, make sure it's all sealed, properly sealed. It's a fix.
Okay.
We see that a lot. A lot of people
Yeah.
try to rig the suction line just to feel how it's, alcohol it is, whatever name it is. Like that.
Yeah, like this one's all torn up. People messing with the suction line.
Yep.
Now inside on a suction line from the manufacturer, there's this little clip in there, little metal clip. Clips onto the bottom of it. And it's to collect drips that come down the line and drip it down into the pan rather than letting them run down the inside of our insulation. So if the suction line was actually pitched like this, and on the inside all that cold copper is condensating, it would ride down the suction line into the inside of this insulation, even if it was sealed here. So whenever I have a little problem like that, I'll insulate it, and I'll often take the suction and just pitch it up slightly. Bend that copper just a little bit so that my drain, anything collecting on the inside of here, coming down drips off of here, actually rides down. The biggest issue when you have it on your platform is that these gaps and seams and the overlaying insulation points around the edges of the air handler, including this one right here, maybe around this, warm air is being pulled in and it's creating a area for condensation to form. And then water is building up. It can, like this will be soaking wet, this whole top panel here. This is above the coil, but it can be soaking wet from condensation along all the gaps. So you take off your panel and you put some insulation tape along the edge, all the way across this whole thing, close it up. It's a little hard to get it closed and tightened down. But you're re-insulating what the manufacturer has designed a little bit faulty in some of the cheapskate designs of insulation right now. There's too many gaps there. And so you re-insulate all of that from the inside, and you can prevent that water that piles up on there and then runs down the inside of these panels and drips off the bottom here and collects on our platform. The other thing is if the coil is pushed against the panel, you turn it around, you open it, you see the imprint of the coil, then you know that potentially the water's coming down the coil, dripping onto that panel and riding the panel down and missing the pan and actually going down in there. So you could push the coil back, you could bend some of those tubes or put some insulation tape against that coil to prevent that from happening.
Also, if the door insulation itself is sticking into the drain pan, especially on that small panel after repair, I've seen it where the insulation is actually in the drain pan, it'll soak it up like a sponge.
Yeah, it'll keep riding up that, crawling upwards.
Also,
2-inch filters does not equal 1 4-inch filter. That equals airflow restriction.
I got one more. On the inside of those drain port connections, there is a plug between the split switch and the main drain connection. A lot of times that falls out, so it won't show up until you try and fill the pan, and it won't leak until you're filling up and backing up the drain. If you reach your hand in there, you can put a little thumb gum into that thing that should have a plug, and it'll stop it from dripping on the outside when the drain backs up.
Typically, it should always go into the float switch before it does that. So that would let you know your float switch is pitched, coming out, not pitched down, or your whole air handler is slightly off level, and it should never dump into that little port before it goes into your float switch. But yeah, if you need to, seal the port. Yeah. But it also lets you know something else is going on. That's it for the day.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.